So you know how to use the unit circle to find the sine, cosine, tangent, secant, cosecant, cotangent of an angle, provided it's on this wheel. But what do you do about the angles that are not on the wheel? For instance, let's take 7 pi. Well, 7 pi is not on this wheel. This wheel only goes up to 2 pi. And in fact, if I were to draw a picture of 7 pi, here's my x-axis, here's my y-axis, here's the circle I draw around my angle. I always start here. This is the initial side, always. And let's do that in a different color. So here I am starting at 0. Around to here, that would be 1 pi, 2 pi, remember 1 pi is the same as 180 degrees, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi would get me to right there. So that's where my terminal side would be, pointed to the left. Well, when you want to find the sine, cosine, whatever trig value you need of an angle that's not on the unit circle, just figure out where it lands the same as. So for instance, 7 pi right here is pointing straight to the left. And when I look at pointing straight to the left, I see the point -1, 0. And on the unit circle, cosine is x divided by radius. X is -1. The radius of the unit circle is always 1. So -1 divided by radius of 1 gives me that the cosine of 7 pi is -1. Now what if I run into something even weirder? What if, for instance, I needed to find the secant of 11 pi over 3? Secant 11 pi over 3. Well, again, I can look at my unit circle. My unit circle has 0 pi over 3, 1 pi over 3, 2 pi over 3, 3 over 3, 4 over 3, 5 over 3, 6 over 3, 7 over 3, you see how I've gone around but I'm still counting, 8 over 3, 9, 10, 11 over 3. So we see that 11 pi over 3 lands right here in quadrant 4, and it's the same location as 5 pi over 3. So I can say that the secant of 11 pi over 3 is the same as the secant of 5 pi over 3, because they end at the same spot. They are coterminal. And the secant of 5 pi over 3, well, remember, secant is radius over x. And the radius of the unit circle is 1 over x is 1/2. So I have 1 over 1/2, 2. So I now know that the secant of 11 pi over 3 is 2. Let's try a couple more of those. How about sine of -2 pi over 3? I want to find the sine -2 pi over 3. Well, let's look at where that is. Negative means go clockwise. So if I were to find normal pi over 3, I would start here, and I would go positive pi over 3, then one more makes 2 pi over 3. But now I need the negative, so I got to go the other way around. I got to go clockwise. So pi over 3 would put me here where 5 pi over 3 is. And then -2 pi over 3 puts me there where 4 pi over 3 is. So the sine of -2 pi over 3 is the same as the sine of 4 pi over 3. And sine is y over radius. The radius of the unit circle is always 1. So the sine is y, which is -√3 over 2, divided by 1 is -√3 over 2. Let's do one more, and I'll show you a different way you can approach the same problem. We're going to do tangent of -15 pi over 4. tangent of negative 15 pi over 4. Now that's definitely not on the unit circle. And I showed you already a way to find where it would be by counting around the circle. In this case, since it's a negative angle, we would go clockwise. Now there's another approach you can take. Since you always get the same value for the trig function so long as you're coterminal, what I can ask is, what's coterminal to negative 15 pi over 4? Well, we know from doing coterminal before, you find coterminals by adding a full circle or subtracting a full circle. So I'm going to take negative 15 pi over 4, and I'm going to try adding a full circle to it. What's a full circle? 2 pi is a full circle. Now, can I add 2 pi to 15 pi over 4? Sure I can, provided they have a common denominator. So let me change 2 pi into 8 pi over 4. 8 divided by 4 is 2, so this still says 2 pi. Now I have negative 15 pi over 4 plus 8 pi over 4 gives me negative 7 pi over 4. So let's take a look. Is negative 7 pi over 4 on this circle? It's not, because the unit circle doesn't show any negative angles. So let's try doing it again. So now I'm going to take negative 7 pi over 4, and I'm going to add 2 pi, which is 8 pi over 4 again, and this time negative 7 plus 8 gives me pi over 4. And that is on the unit circle. So now I can say the tangent of negative 15 pi over 4 is the same as the tangent of regular old plain old 1 pi over 4, which we know from practicing is y over x. So I look over here at pi over 4. Y is square root of 2 over 2, over x is square root of 2 over 2. And anytime you divide something by itself, of course, you get 1. So the tangent of negative 15 pi over 4 is 1. So there's two ways you can go about finding trig values that are not on the unit circle. You can draw a picture and go around the circle, or you can add or subtract complete circles, 2 pi, until you get a number that is on the unit circle.